Here's a classic intermediate algebra question. It talks about two trains that leave a station at the same time, and after 4.5 hours, they are 450 miles apart. So here's a picture. Let's pretend that this line represents a train station. The first train travels 4.5 hours and ends up here. The second train travels 4.5 hours and ends up there. Again, after those 4.5 hours, the story problem says that they are a total of 450 miles apart. In other words, the distance for train A, let's say distance for train A, and we'll call this A, and the distance for train B, when we add those two distances together after 4.5 hours, distance A plus distance B, we get a total of 450 miles. So basically, this is the foundation for our equation. In order to get a variable or to solve this equation, we need to know a little bit more about distance. Something we learned earlier is that speed is equal to distance over time. Just like your cars, if you travel some kind of miles per hour, miles is distance and hours is time. So I'm going to write down the formula or the equation. Speed is equal to distance over time. Now, since the equation that we want to use, which I will circle in orange, has distance plus distance equals 450, I want to take this equation here and solve for distance. And in order to solve for distance, just like we've done in our other rational equations, we would multiply both sides, in this case, by time, multiply speed by time, to get the distance all by itself. In other words, I'm clearing my denominator, or clearing my fractions of my denominator time. When I do it on the right-hand side, the times cancel out, and I get distance equals speed times time. Or if it helps, we could just say d is equal to st or ts. It doesn't matter which way we write it. But d is equal to ts, and now I'm going to bring that back into this equation and rewrite my equation. Let's change colors. So if I have distance of A and distance of B is equal to 450, really what I'm going to say is I'm going to say distance, which is s times t, and this is for train A. Oops, that's a little messy. Plus distance for B, which is also an s times t for B. When I add those two together, I should get 450 miles. So now all we have to do is we have to look through the story problem and figure out if we know anything about speed or time for train A and train B. It doesn't really matter which one's which in this case. What it does say is that one train travels 10 miles per hour faster than the other. So what I am going to do is I'm going to say right off the bat, hey, I need to know something about a speed. Since I know this one is 10 miles an hour faster, why don't we say let x equal train A speed. I need some kind of variable, and I need to have this let statement that will inform me and you what x really stands for. And if x is equal to train A speed, then automatically I can take this s that's in my equation for A, and I can call that x. And my t is representative of time, and we recognize that it was 4.5 hours later, so I'm going to write x times 4.5, or I could reverse it and say 4.5 times x, plus speed for the second train. Now the second train is 10 miles an hour faster. Faster in mathematics is usually represented by addition. So I would say x plus 10. And then I would multiply that by time, which is in this case, again, 4.5 hours. Altogether, the total distance is 450, and that is our equation. I'll take it one step further, and then I'll let you wrap it up from there. But I will have 4.5x for the first expression, distribute in the 4.5 to get 4.5x plus 45 is equal to 450. And after that, you'll combine like terms to get 9x plus 45 equals 450. Subtract the 45 from both sides, divide by 9, and you will have x is equal to some value which hopefully makes sense. Always double check your answers, At the very end, I want you to say something like, the speed of the train is blank miles per hour. Make sure you solve for x to get that blank. Hope this helps.